Hello, everybody. Welcome back. We are on episode 3 of the introductory week materials. This is the last of the 3 episodes of this particular concept. And what we're going to do in this episode is talk about a model that sort of encapsulates many of the concepts that we've discussed thus far in the course. Specifically, it's called the model of production possibilities. And what it's going to help us illustrate are concepts of opportunity cost. It's going to help us illustrate concepts of those goals of efficiency, technical and economic efficiency from the last episode, to show concepts of growth and some other concepts that we've been talking about along the way. Before we get into this specific model, and it's just a good introductory model that helps us to understand graphing and to show some of those concepts and get us kind of revved up a little bit for the rest of the course, it's an important thing to talk about the value of modeling. So we're going to do that for just a couple of minutes, and then we'll actually look at this specific model. Economists use models all the time, as do lots of other scientists. And the reason that we use models is because the world is a really complex place. It's not an easy thing to understand why people behave the way they do. And so if we can come up with a model that simplifies the story and makes it something that's understandable to us and has predictive power. So time and time again, that model gives us the correct prediction, then it's a good model. Sometimes students get frustrated with models in econ. They say, hey, Dr. Ron, that's not exactly how the real world works. And my answer to that comment is, you're right. These models do not capture the full complexity of economic life. And that's okay, as long as the models predict well. If they didn't predict well, then we would scrap the model, the old scientific method idea, and we would come up with a new model. But if they predict well time and time again, and they help us to deal with an overly complex reality in a meaningful and manageable way, then they're a valuable model. You know what? We use models all the time. You probably have on your cell phone or on the wall of your house or on your computer somewhere, even on your computer, a clock, right? And that clock right now reads whatever time it is right now as you're watching this video. Does that clock fully model the complexities of the passage of time? No, right? It's a model. It doesn't capture things like, losing your hair. I mean, who thought this was going to happen 20 years ago? I knew it was possible, but my goodness. But the story is, it doesn't capture every complexity of the passage of time, but it's a good model. Because what it tells us is, if we have a commitment or an appointment, then we know that at X time we need to be in a certain spot. The other parties that we're going to be dealing with are going to be there as well. And so the model works for our purposes. If it didn't, we'd have to revise the model. Let me just tell you kind of a little humorous story. My daughter Katie, when she was really little, she was in, I don't know, kindergarten or first grade or something like that. She came home with pictures. Kids always draw pictures, and you love to see that, but it's a little dangerous as a parent. Because you look at the picture and like, oh, that's a beautiful, and then you're like, uh-oh, I'm in trouble no matter what I say, because chances are I'm going to get it wrong, right? That's not what it was. I'm sorry. Oh, that, So the story is that she came home with lots of pictures, and they were all cute. Here's one that I remember specifically. Don't worry about the rest of this graph here. She came home with this picture of this really tall, remember she's a little short kindergartner or first grader, this tall individual, right? And it looked like this. I knew that was me, right? That's a model of her dad. From her perspective, tall guy, she didn't capture every complexity of Ron Dunbar in this picture, far from it. But the story was, I got the message. It helped her to understand and me to understand what she was getting at, and so it was a useful model. So we're going to talk about modeling a great deal in this class, and I'm going to talk about the first model of the course, which is the model of production possibilities. So please look at your note set here that you printed off, and there's a definition already given to you for the production possibilities frontier. And basically what it shows is the maximum output that a nation or an individual or whoever could produce given three things: the existing technology that they have, so the way they know how to use their inputs to produce outputs, and given the amount of those inputs, and given the quality of those inputs. So again, with the technology and the quantity and quality of inputs that you currently have, what are the maximum output combinations possible? What are the production possibilities? And so that's what a PPF, a production possibility frontier graph, is going to show. Now, for simplicity, I'm going to start with one example that relates to an overall economy, and then you guys will have a chance with an exercise to do a production possibility frontier question related to your life as a student in a little bit. But for this example, I'm going to make a simplifying assumption. I'm going to assume that our nation can only produce two things. Okay? We can produce what are known as consumption goods. And so you want to write that on the sheet there where it says the nation can only produce two things. Consumption goods. And you can think about consumption goods as stuff for today. Right? So things that we consume right now. Food and energy and clothing and stuff like that. So consumption goods are stuff for today. Or this nation could produce capital goods. Capital goods are sometimes called investments or investment goods. And you can think about them as stuff for tomorrow, for the future, for investment and growth. And so you're like, why did you only pick those two goods? The answer is I only know how to draw things in two space. I can't draw very well in multiple dimensions beyond two. And so we made a simplifying assumption. But this is going to help us to think about the trade-offs, the opportunity costs that we face in producing things that we want right now versus saving and investing for the future. So we've got those two goods that we could produce with the technology and the quantity and quality of inputs our nation currently has. And so look at the data here. And I showed you 5 possible combinations the nation could produce, A, B, C, D, and E. And these represent coordinate pairs. So what it says is, you know, for example, if this nation put nothing into the production of consumption goods, and all of our inputs, land, labor, capital, entrepreneurship, into making capital goods, we could get 300 of them. Or alternatively, if we put some resources into making consumption goods, enough to get 100 units of those output, we could only produce 275 capital goods because we took some resources away to put it over here. Or we could, these are all possibilities, put enough resources into making 200 consumption goods but only get 225 capital, all the way down to point E, where if we put everything into having fun stuff for today, talk about a party, and who cares about those kids and grandkids for the future? Who needs them? That's a joke. The story is we wouldn't have any capital goods. So these are all production possibilities. What you need to be able to do with a model like this is just use these numbers and interpret them, not derive them. Okay? So let's look at that data, and I have a series of questions that I want to ask you. They're underneath your graph there. And the first question says, look at this and answer my question of what is the opportunity cost? What does this nation sacrifice if they move from combination A to combination B and they produce 100 more units of consumption goods? So if you go from A to B and produce 100 more consumption goods, what's the opportunity cost, the opportunity lost? Well, 25 fewer capital goods, right? So minus 25. So there's the opportunity cost. Produce 100 more of consumption, lose 25 of capital. That's the trade-off. Question 2 says, well, what's the opportunity cost of going from B to C and producing yet 100 more consumption goods? And if you look at the math here, that means capital good production goes from 275 down to 225, which is a loss of 50 capital goods. And if you answer the next question and go from C to D and produce 100 more consumption goods, the sacrifice gets even bigger. Now it's 75 lost capital goods. And from D to E, the last of these questions, when you get 100 more consumption goods, you give up 150 more capital goods. Okay? So that clearly shows the trade-offs in a numeric specific sense in terms of the trade-offs, the opportunity costs. The question becomes, or the next question, question 5 says, look at this for a second, and as we keep on increasing consumption goods by the same amount, 100 units each time, the lost capital goods keeps on getting larger. So it's a bigger sacrifice. That means opportunity cost is not constant. The sacrifice is not constant. The sacrifice is getting bigger and bigger and bigger. And economists call that the law of increasing opportunity costs. But I want us to think about why that's happening. What's going on here that leads to a situation where that opportunity cost is getting ever bigger? Some of you might be thinking, well, it's because when we produce more consumption goods, we don't have as many inputs to produce capital goods, and so we lose them. That's not the whole answer here. That just tells me that there is a trade-off, that if you produce more of one, you have to give up some of the other. It doesn't tell me why the trade-off's getting ever larger. The reason that the trade-off gets ever larger, if you're answering question 5 there, is because inputs are not equally good. They're not equally good at all tasks. Or to use the language of economics, inputs are imperfect substitutes for each other. Imperfect substitutes. Inputs are not equally good at all tasks. They're imperfect substitutes for each other. I mean, think about it this way, right? I think I'm a pretty good economics teacher. And I also love the sport of baseball. I was a heck of a midget league catcher, about as far as I got. But the story is that, I really like economics. I'm not that great at baseball. Ryan Braun, on the other hand, is a really good baseball player, even without the drugs. And the story is that I don't think he's that great of an economics teacher. So what if we traded places? What if they put me out in the outfield for the Brewers, and they put Ryan Braun in the classroom or in the video here teaching economics? Would we get the same output, the same outcome? No. We're not interchangeable, right? We're not perfect substitutes for it. Could he teach economics some? Sure. Could I play baseball a little? Sure. But we wouldn't get the same output because we're not equally good at all tasks. And so that explains it. I mean, let me give you one example that was kind of a classic example used for many, many years in every economics textbook. Oftentimes we talk about the debate between whether our nation should produce, and I'll put it in quotes here, butter, or we should put our resources into making guns. And you'll oftentimes hear butter versus guns. And the idea is, do we invest money in the military industrial complex, quote unquote, making machines and guns and all that kind of stuff, or do we put our resources into making food and all that kind of stuff for our people? And so think about this, right? Here's the story. Here's the story. Here's what's going on. At point A, all of the resources, all of the workers, everything else are in the gun factories. And we get 300 guns. But what if we take some workers out that really weren't very good gun makers and we put them out there on the farms making butter? Well, we gain 100, and what do we give up? Not much, because those workers were really farmers, and we had them out there in the gun factories. So we don't lose much. But let's keep on putting more and more workers out into the fields or out into the farms with their bib overalls and their country hats and all that kind of stuff. As we do that, as we get ever more workers out into the farms, we start to get workers that really are better at making guns. To the point at the end here, these really are gunsmiths. They stink as farmers. And so the sacrifice of guns gets ever bigger as we produce more and more butter. It goes the other way too. If we treated this one the other direction, we'd see the same thing. As we make more and more guns, we give up ever larger amounts of butter. We're not perfect substitutes for each other. Y'all know that. There's some things you're really good at, some other things not quite as good at. And so that is the driver of this law called the law of increasing opportunity cost. What it says, like it says on your sheet there, is as we produce more and more of one good, we sacrifice ever larger amounts of the other good. Not just more of the other good, but ever larger amounts of the other good. Guns versus butter. Ryan Braun and Ron Dunbar are not perfect substitutes in baseball and economics. Okay? So that law of increasing opportunity cost is going to have an impact on what our graph looks like for production possibilities. And I'm going to get rid of this writing. And I'm going to get rid of a couple other things so we can focus on the graph here. So what's going to happen when we graph the production possibilities frontier is that law of increasing opportunity cost, Ryan, Brown, and Ron Dunbar, is going to mean that the PPF is not a straight line. It's going to have a curve to it, as we'll see here in just a second. So let's plot the points that we had from over here. One possibility for this nation is combination A, this coordinate pair. No consumption goods and 300 capital goods. So I've got consumption goods. If you haven't flipped already to page 8, please do so. The amount of consumption goods on the X or horizontal axis and the amount of capital goods on the Y or vertical axis. And so point A says no consumption goods, so that's the origin, and 300 capital goods. So that's this point, call it point A, 0, 300. Okay? Or, alternatively, we could produce combination B, which if you look over there, is 100 consumption and 275 capital. So 275 on the graph would be about there, and that's combination B. 100 consumption, 275 capital. Or we could produce combination C, right? 200 consumption goods and 225 capital. So here's 225 on the y-axis. That's combination C. 200, 225. Or we could do D, right, with our inputs and the technology we have. D is 300 consumption and 150 capital. That's here, 300, 150. Or we could have a partay today, and don't worry about those snot-nosed kids. I don't call my kids that. That's a joke. And that would be to produce all consumption goods and no capital goods, and that's down here as the x-intercept at point E, 400 and 0. Those are only 5 possible pairs. There's obviously more than that because we could produce a combination between any of these points. And so what I'm going to do is I'm going to connect the dots and smooth it. And I'm going to say that what this graph is this nation's production possibilities frontier. Okay? Go back to the definition, at least in your head, and what this shows is the maximum possible combinations that we could produce given the technology and the quantity and quality of inputs we currently have. That's why we call this a frontier. Because if you think about this, it says, hey, we can get up to this graph right now with the technology and the inputs we have, but we can't currently go any further. And so it's our outer combination. It's the frontier, the most we could possibly produce. Okay? So then I want us to think about what this graph shows related to the concepts we've been talking about. And to make some room here, I'm going to erase these data because we've got it in the picture. And so you'll notice that under this graph on page 8, I've got some questions for you about lessons that are learned. So the first lesson has to do with opportunity cost. Where does opportunity cost show up in the graph? Well, here's where it shows up, right? If we go from A to B, which means we produce 100 more consumption goods, we all know from the calculations we just did a few minutes ago that you lose 25 capital goods. To me, that looks like the slope because it's the rise over the run. You have to give up 25 to get 100. And so the slope of the line between A and B is the opportunity cost. It's what we have to sacrifice of one to get more of the other. So if you're writing it down on your notes, opportunity cost is shown in the model as the slope, right? Opportunity cost equals the slope of the production possibility frontier between any 2 points. Opportunity cost is the slope, the rate of trade-off of the PPF between 2 points. What happens to the slope, though, as we go A to B, B to C, C to D, D to E? Well, the slope gets steeper. It's a negative number, but it gets bigger in absolute value. And so what we know is that the opportunity cost, the trade-off, gets bigger, right? To get 100 from B to C, you give up 50. To get 100 more from C to D, you go from 225 down to 150. You lose 75. And to go from C to D to get 100, you give up a whole 150. The fact that inputs aren't equally good at all things, that Ryan Braun and Ron Dunbar are not perfect substitutes in baseball and economics, explains why this PPC curve is not straight line. It's not linear. Rather, it's what we call concave to the origin. And so the shape here is concave to the origin. It's just like if you're at the origin, you're standing inside of a cave. So concavity to the origin means that it looks like you're in a cave when you're looking at the origin. Okay? So that's the story of opportunity cost and what's happening along the curve. Let me add a couple of additional points on here. I want you to do the same thing on your graph. I want you to add a point underneath the curve, somewhere down here, wherever you want to label it, and I want you to call it U. And then I want you to take a point, that's beyond the curve, way out here, and we're going to call it point I. So please add those in. And I want to talk about what each of the points on here represents related to what we've been talking about. So first of all, look at your notes there. Question 2 says, what do you know about all the points on the curve? Like A, B, C, D, E, and every other point, right, that's directly on the curve. What does that represent that we talked about in the last episode, episode 2? Well, if you said it was efficiency, you're right, because the story is that each of those points is a maximum combination possible with the inputs we have. So all of the points on the curve, right, all the points on the curve by definition are technically efficient. So they represent points of technical efficiency. Technical efficiency. All right. Which one of those, however it says in your sheet, which one is the best? Which one is the economically efficient point? Where do we want to be? A, B, C, D, E, something else? And if your answer is, well, I don't know, it depends, you're right. That's my favorite answer in all of economics, by the way, is it depends. But the answer is it depends, because if the society says, we don't care about the future, let's have a partay, then E is where we're going to go. That's where we're going to throw our money in capitalism, and that's what's going to determine where we want to be. On the other hand, if we just care about the future and we don't care about today at all, we only care about the future, A might be where we want to be. In reality, we're going to want to be somewhere in the middle of those. But is it going to be B or C or D? It depends upon how we value today versus tomorrow, how we're willing to throw our money into things that benefit us right now or are going to benefit us all long term in terms of our future kids and grandkids and all that kind of stuff. And I don't have the answer for that up here. That's not a model that we're developing right now, but the answer is only one of those points is the best, is economically efficient, and I don't have that set on here. So only one, right? All the points on the curve are technically efficient, but only one of those is best. And so only one is economically efficient. Economically efficient. And the best one is determined by what we value. So in capitalism, it's prices. What are you willing to spend your money on? In a command control system, the government says you want to be here. That is the way it is, right? You want to be here. Tradition says, no, you want to be here or whatever, and whatever that society uses as their allocating mechanism determines where we want to be. Okay, our system is based on prices, where we're willing to throw our money. All right. Then I want you to look at, since we've got the points on the curve and we know that they're efficiency concepts, what do you know about a point like U? A point like U is a combination where the amount of both goods is less than what we could produce if we were doing our best. So a point like U is a point of inefficiency. We're not up to our potential. You know, the way I like to think about U is it's the Chicago Cubs. I'm a baseball fan. I like the Brewers, even though the Brewers were this way last year as well, and most years. But the story is that U is a point of waste. And I use the letter U because it reflects unemployment or underemployment or waste. We're not reaching our potential. I mean, I've already done that today too, right? I woke up this morning like, I'm going to be all I can be, Dr. Ron. I don't talk to myself like that, Ron. And the story was that I've goofed, right? I've told some jokes. I've been silly. I've daydreamed. I've lost my track, whatever, right? So the story is I'm not quite at my potential. So all points like U, all points under or inside the curve, right, are possible to achieve, but inefficient. Inefficient, or they represent concepts of unemployment, waste, or underemployment. People with a PhD in physics working at McDonald's, right, that kind of stuff. So they're the Chicago Cubs. So everything underneath is possible, but we're not doing the best that we can. So then what do you know about points out here like point I? What do we know about points that are beyond the production possibility frontier like point I? And if you look at that and you say, well, the blue line, the curve here is the frontier, that's the best we can do, then I is currently impossible. Right? The points that are outside or beyond are currently impossible. Currently impossible. We just can't get there. You know why? We don't have enough technology. We don't have enough resources, inputs. We don't have good enough inputs to get there right now. Would we like to get there? Most of us would say, yeah, I'd like to get there, right? I'd like to be able to produce more of everything in the future. And so what that would look like would be a situation where we would have economic growth. Now, economic growth can happen a couple of different ways, as your book notes and all that kind of stuff. But the vision is that we would like to get the PPF to shift outward, to have a new production possibility frontier, call it PPF prime, where we could have more of everything. And that shift to the right or out would be indicative of economic growth. Now, sometimes growth is general, where it shifts out in a parallel fashion, like what I drew here. Sometimes growth only affects one sector or the other, like capital goods only or growth in consumption goods only. And then rather than a parallel shift, we'd have a rotation, which would affect different sectors differently. But I'm not going to worry about that in terms of any test questions or that kind of stuff for this particular course. Okay? So my question for you, though, is how do we achieve this economic growth? How do we get out to a point like I in the future? And I think you know the answer, because this blue line, this frontier, is fixed by the technology we have. But what if we have new technology? That would do it, right? We could produce more of everything with the inputs we currently have. So an improvement in technology would lead to economic growth. A second thing that was held constant with this blue line that constrains it is how many inputs we have, how many workers, how much capital, how much land, raw materials, and all that kind of stuff. And if we have more of them, then that would allow us to have growth. So an increase in the quantity of inputs would also lead to economic growth. What are some examples there of an increase in the quantity of inputs? Because I'll often ask questions like this on quizzes and exams. One would be something like, what happens if we discover new sources of crude oil in our country? Or how about all of that natural gas that they're dealing with the fracking out in the Dakotas and other places? I'm not saying that's all good. That's not the point of this, right? We'll talk about the challenges and the costs and the environment and other things in a little bit. But the story is we have more resources, so our nation as a whole can produce more than they could previously. Or if we have a situation where we have immigration, we have more people coming into the country than are leaving the country. In that case, we can simply produce more than we could have previously. So if we have a net positive immigration status, then our growth will occur, our possibilities will expand. That's a second one. A third one is an increase in the quality, not the amount, but the quality of our inputs. Increased quality of the inputs that we have. So if our people that are in the education system do a better job and our population is more highly educated, then our possibilities expand. Improvements in quality with education, other sorts of things will allow us to produce more than we ever could in the past. That's what you guys are investing in. I'm hopeful, right, that if we keep doing that and doing it better and better, the story is that our country will get even better. And so growth can occur. And then there's one more. This is number 4. And I don't have room down there, and I'm too tall, and it's not going to work. But and that is that. Let me ask you this. Look at this graph. Remember, consumption goods are down here, stuff for today, and investment or capital goods are up there, stuff for tomorrow. So where are we going to have a better tomorrow if we produce closer to A or closer to E? Closer to A or closer to E? What will lead to more growth in the future? Yeah, closer to A. Because A is producing a lot of capital goods today, saving and investing a lot today. And if we save and don't spend, but invest today, tomorrow will be a brighter day. If you spend all your money today, you don't have any savings, it's going to be tougher tomorrow. But if you don't spend it all today, you sock some away, right? You think about retirement, tomorrow will be better. You'll have that opportunity to reap those rewards. So the answer is if we produce more capital goods today, closer to points like A and B, right? The more future growth we will have. We don't actually want to be at A. That would be terrible. We wouldn't have food today. But the closer we are in that direction on the graph, the more growth we're going to have in the future. Okay? So those are the factors that shift the production possibility curve to the right, which indicates economic growth. If you have questions about this, don't hesitate to ask me, an email or give me a call or whatever. Just for completeness, please note, of course, that a nation's production possibility curve could shift the other way. So if we started at the red line right now, and we had a situation where technology was destroyed, or inputs were destroyed or ran out, or the input quality was diminished, or we just said, it's all about today, don't worry about the future, tomorrow will not be as bright, and we would have the curve shift back to the left or inward. Our possibilities would shrink. So some examples to think about might be a disease pandemic, heaven forbid, where we saw a massive number of individuals who lost their lives because of that, or we saw a tornado, or we saw a hurricane, or we saw an earthquake, or some other natural disaster that destroyed technology, or war. War is a good example, where we lost resources that would shrink our production possibilities and shift it back to the left or inward. Okay. So hopefully this is going well. It's a good model. It illustrates concepts of growth and efficiency and opportunity cost. I want to do one last aspect, and then we'll wrap this section up here in just a couple moments. If you look at page 9, page 9 asks a question that is the hardest one of this whole set that sometimes students struggle with. So please pay attention to this one. Maybe mark it up, asterisk it, and say, hey, don't forget this one, because this is a little bit confusing perhaps. What it says is, how does a change in unemployment of existing resources, and existing, that's a key word here, show up in this model? So what if unemployment falls? Unemployment right now is about 7%. What if it falls to about 6%? What's going to happen in this graph? Some of you might be saying, well, if there's less unemployment, then the curve shifts to the right. But that's not what happens here, because we didn't come up with any more inputs or any better inputs or any new technology. All that happened with less unemployment of existing resources is we're not wasting as much. And so we're closer to our potential. Think about it this way. If point U that we drew before represents 7% unemployment rate, and unemployment rate falls to 6%, right? U prime here, 6%. All we did was move closer to the existing PPC, the blue line. Nothing shifted. Again, we don't have any new technology, new inputs, or better quality inputs. We're just using more of what we already had. So on your blank, if you didn't write anything down, a decrease in unemployment is a move closer to the existing, and existing is the key word, PPF, right? A move closer to the existing PPF. I know a couple of times today I've called it a PPC, production possibilities curve. That's the same thing as a PPF, a production possibilities frontier. And different people use those words interchangeably. I'll call it a PPF for your purposes when it comes to tests and stuff, but sometimes I slip into that language and I just caught myself, so I do apologize. But if you move, from 7% to 6% unemployment, there's less waste, less inefficiency, and we move closer to the curve, not a shift of it. Likewise, for the second one, if there's a higher unemployment rate rises to, let's say, 8%, then you move further away from the existing PPC, right? So you move further away from the existing PPC because we're wasting more of what we already have, okay? So that's the production possibilities model, a good introduction to modeling, a good chance to see opportunity cost, efficiency, growth, those concepts in action. And just so you think about this in a little different way, we don't have to talk about a PPC just for a country. We can talk about a PPC curve for you as a student. And so you were supposed to print this one-page sheet off from the Blackboard site, and it looks at you as a student studying for 2 exams. And I want you to take a look at that. The answer key is on Blackboard as well, so you can take a peek. But to see that, hey, you face those same trade-offs, right? And efficiency and growth and all those concepts. So you've got two exams to study for. You've got history or math, and psychology. And depending upon how you use your hours of study, you're going to get different outcomes on the 2 exams. And so we can look at opportunity cost. We can look at efficiency or inefficiency. Inefficiency down here is like going on Facebook or Twitter or whatever, Instagram or whatever, while you're supposed to be studying for econ. So you're really not studying to your utmost. You're performing underneath your potential. A point like I, which is a higher score than what you can get here, means you've got to figure out a new way to do things, a new technology or more hours or what have you. So take a look at that and play with it. It's not an assignment. It's something, well, it is an assignment in the sense that you should do it, but it's not something that you have to turn in for me. The answer key is there on Blackboard. Okay? So that's the model of production possibilities. Our first model, by no means our last. We've got 2 little housekeeping details to take care of before we call it a lesson or an episode. Let me get rid of some of this. Before we do that, you know why the fish got kicked out of school? He was caught with seaweed. No? You don't like that? Okay. But seriously, 2 last additional miscellaneous concepts to cover very quickly here. In economics, there are 2 major branches. There's microeconomics, which is what this class is about, and then there's macroeconomics. And you just need to make sure that you know the distinction between the 2, micro versus macro. And when it comes to micro, I think the name's pretty descriptive because like in science class, when you look through a microscope, you're looking at things at their smallest level. And that's what micro is in economics, right? It deals with questions of individual level stuff. So individual deals with individual level outcomes. Individual consumers and how they choose what to buy. How do you choose how many cookies to buy in a week and how much bread and how much beer and how much whatever? So individual consumers, individual businesses. How does Pepsi Cola decide what price to charge for Pepsi? Like that's a microeconomic topic, etc. So it's all about individual level stuff, individual consumers and individual businesses. So if you see a statement about what's happening to the tuition costs at Madison College, that's a microeconomic topic. Or why do people choose to work fewer hours when their tax rate goes down, for example, might be a microeconomic topic. That's to be contrasted with macro. And macro is the overall economy, the big picture. So macro is what I said, deals with overall features of the economy, right? Overall features of the economy. Much bigger. And when you think about that, there might be some examples to talk about, like, for example, the unemployment rate, let's say, is 7%. That's a macro topic, right? Because it's talking about what's happening for the overall U.S. economy. A micro version of something like this would be what's happening to the job status of Joe the plumber. Does he have a job? Is he looking for a job? That kind of stuff is a micro topic. But the macro topic says, well, for the whole economy or the state of Wisconsin, unemployment is X%. Or it might be talking about what's happening to price levels across the economy. Are they increasing? In which case we have inflation, or decreasing, and that sort of thing. Not what's happening to the price of Pepsi Cola, but what's happening to the cost of living across the economy. That's macro. And just a couple of comments real quick. Some people, in fact, these are relative concepts. Like, for example, is the rate of unemployment in the city of Madison a micro topic or a macro topic? The answer is compared to what? I mean, it's more micro than for the whole state, which is more micro than for the whole country, which would be more micro than North America, which would be more micro than the world. On the other hand, right, the employment rate or the unemployment rate in the city of Madison is a little bit more macro than the situation for what about Joe the plumber. And so it is relative. And in fact, some people even, just so you know, say that there is no such thing as macroeconomics. That if you look at micro and you add up the decisions of all the individual makers, the consumers and the businesses, all we get is the total. So that macro is sort of this made-up branch. Macroeconomics came into being in the 1930s when we lived through the Great Depression, and a gentleman by the name of Lord John Maynard Keynes said, hey, we need to think about the overall economy so we can try to get it back on track. And so there really was no branch of macroeconomics until that time, and it is a bit of an artificial distinction. Just so you know, what I'll do on a test or quiz is I'll say, of the following, which is the most macro topic or the most micro topic? And that's the way you should think about this. But you'll hear the terms thrown around, and you need to know the distinction. Okay? And then I've got one last house cleaning detail, one last terminology here to do, and that is to make a distinction between what are known as positive economic statements or positive economics and normative economic statements. Positive versus normative economic statements. Econ is really good at making positive statements because they are testable. So these are statements that can be tested with data and verified or proven false, right? they can be tested with data and verified or made clear that it's not correct. So, for example, if I tell you the unemployment rate is 7%, then we can use data based on our definition of an unemployment rate, and we can see if that's true or not. I can talk about what's happening to the average cost of living, the inflation rate, and I can measure that. I can say that the average wage for an economist right now in the United States is about $89,000 a year. I can test that, right? That's a statement of fact, right? They're statements of fact. Statements of what is, right? And economics can obviously do a good job, at least potentially, looking at this and actually measuring those concepts. But normative statements are also important. The problem is they're not provable. They're not fully testable. Okay? So these are statements that are based on your values and mine. In sociology, a norm has to do with your values, right? What does the society think is best? And so these are value-based statements. You can think of them, if you want, as opinions. They're not fully testable. I can't prove that they're right or wrong, right? So they're not fully testable. So somebody might say that we should have universal health care. How do I prove that? I can't prove that. What I can do, of course, is do some studies and say, if we do this, here will be the results. Those are positive statements, you know, that when this happened, this was the result. But I can't necessarily say we should do it. I can't prove that we should do anything. Or if I said that the unemployment rate in this country should be 5%, I can't prove that. So normative statements are value-laden statements. Lots of people will use those. In fact, we have to make normative statements. We have to ultimately decide what we want the world to look like. And economics, again, like we talked about at the end of the last episode, can't answer that question. But I want you to be careful because while positive statements are testable, normative statements aren't. And most statements by a lot of politicians and other folks are indeed normative, as they need to be. But we should look at them critically and say, wait a minute. Economics, as we found in this introductory section, is a different way of looking at the world through these first 3 episodes. It's going to give us value in terms of making better choices and understanding what people around us are trying to tell us. I'm excited about economics. It's about the world we live in. It's about how we make better decisions with our limited resources, and I hope you get excited about it as well. It's been good. Have a great day, and we'll talk next week about the concepts of how capitalism uses markets to determine where things should go. Have a great week. Talk to you later. Bye.